Thank you for joining me today for the last session of KubeCon. We made it. All right, yeah, appreciate it. So today we're going to talk about feature flag driven development and how you can seamlessly integrate feature flags into your software delivery lifecycle. I'm Michael Beemer. I work at Dynatrace as a product manager. I've been using feature flags for quite a few years at this point, and I serve on the governance committee of OpenFeature.
All right, hello, everybody. My name is
This is going to
yeah, no kidding. How about? Oh, is it? All right. Hi, I'm Kris Coleman. I'm a director of platform engineering at TestifySec. We're the folks behind the Entoto tools, Witness and Archivista, part of the CNCF. And I've been working on continuous delivery and release on demand. I'm a huge champion for feature flags, very passionate about them. So yeah, let's get started. Who here is already using feature flags today? Raise your hand. Awesome. That is really exciting. If you haven't already gone and checked out OpenFeature, please do. We're looking for more stars. It's a great, great project. Okay, so if you're using feature flags already, how many of you feel like there is a disconnect between your development flow and your flag ops? Raise your hand. Yeah, it's a very, very painful part of the adoption process. We're here today to talk about a solution. So let's talk a little bit about feature flags. Feature flags are powerful. You can do so much with them. Namely, you can separate your deployments from your releases. They give you the power of runtime control. You can toggle flags to change the behavior of features and code paths at runtime. They give you the power of progressive rollouts. You can do canary deployments or even percentage rollouts. Experimentation is super powerful. You can stop making design decisions on your app based on hunches, and you can start doing it on real user engagement. Precise targeting. You can change the behavior of features and code paths for precise user segments. But they're not without their challenges. In traditional feature flag systems, you might run into some of these problems. There's no guarantee that the flag your application code is trying to use actually exists in the upstream provider. Whoops. Runtime errors. You could have typos in your flag name or possibly even a different type of flag. You might expect a Boolean, but really the flag is a string or an object or a number. Context switching. As a developer, flow state is very important. When you're working with the feature flags that are disconnected from your SDLC, you have to constantly switch context, destroying your mental model and slowing down your flow state. Manual coordination. If you work in a cross-functional team environment, oftentimes the owners of feature flags, especially in higher environments like production, might be a different team than the development team working on the features. Coordinating feature flags across those teams can slow things down. So let's talk a little bit about the developer journey with feature flags today without feature flag driven development. Later, Michael's going to show us how we can solve this and make it more streamlined with feature flag driven development. So you get a ticket. The ticket arrives in your queue. It wants you to add a new feature flag for the new checkout flow. Seems easy, right? So first thing you do is you're going to leave your development environment. You're going to open your provider portal probably. That's context switch number one. You're going to start entering the metadata, the variants, and the defaults for this new checkout feature. Now you're ready to code. Context switch two. You go back to your development environment, you start writing the code around the feature, and you're building that mental model back, getting back into that flow state. But now, you have to remember, what was that string literal that we did for the flag key? Did I use kebab case or did I use snake case? Michael's always using different cases. I got to remember. So you copy paste the flag key into your code, and then maybe A couple days pass, you finally get it ready to the point to open a pull request. And the reviewer, very astute reviewer, notices that you introduced a new feature flag. He's concerned, he or she is concerned, that you might have a flag that doesn't exist. So they ask you, what do? Context switch again. You go back to the flag provider and verify that that flag exists and is promoted to the right environments. It's a lot of thrashing going on here, and that's what we aim to solve. Let's talk about the string literal problem a little bit. So in a traditional approach, it would look something like this. You would instantiate your client, and then you would ask for a flag evaluation. Does anybody see some things here that could go wrong? Like show of hands? There's a few things that could go wrong here. So one thing is that we're accessing this key using a string literal, which we could have wrong, right? The other problem is we don't know for certain if this flag was a Boolean flag. What if it was an object, a string, a number? So this leads to uncertainty. Does the flag even exist? Is it the correct type? What's the intent of the flag? There's no metadata around this flag right now. We don't understand what the flag was for, what its purpose or intent was. So we could really use some automation here to make this whole process more seamless and safer and mitigate risk. So I want to talk a little bit about a real world example at Corewell Health. So Corewell Health is like the largest healthcare system in Michigan. And my team was tasked with completely redesigning their digital front door app. At the time, it was a single page application. There were a lot of things that we needed to fix. We wanted patients to have immediate load times. So we wanted to move away from SPA and use static site generated app. But also, we were plagued with 6-week delivery cycles. It wasn't working for anybody. Developers hated it. If something went wrong during the release, it'd be 6 weeks before you could try it again. Leadership absolutely hated it. There was no velocity. So how could we try to achieve release on demand and separate our deployments from our releases, but with a static generated site? So the challenge was we needed atomic deploys, and we needed safe defaults, and we still needed to support the dynamic runtime queries. The solution was we built a custom system that allowed us to pull down the flag state at build time. So it's a reflection of the flags at that time, and then statically generate the site using those states. And then at runtime after deployment, we would re-query for the flag state. So that allowed us to eliminate load times, have immediate paints, and then still flip the flags at runtime. But it still had some problems. It could have been improved. We had shifted the string literal problem from runtime to build time, which pros and cons. But now if something went wrong, a developer has to pull themselves away from their feature development and solve an incident in a CI build. It could have been better. So if you want to read a full case study about how we made feature flags work with static over there. And I am going to hand it off to.
Can you hear me? All right, cool. All right, yeah, thanks, Kris. So yeah, basically, based on Kris's use case and then some of the others, really, the experience using feature flags isn't impossible. I mean, people have been doing it forever, but we feel like it can be improved. And so really, we're at KubeCon, and we can actually look at Kubernetes for inspiration here. So like in Kubernetes, you can declare a desired state. So we asked ourselves, wouldn't it be nice if you could also declare feature flag state? So we'd like to introduce the flag manifest. If you look at it, it's incredibly simple. There is some elegance, I'd say, in the simplicity, but there's not much to it right now. It's basically just a list of feature flags. It has things like the default value in here. So this is the value you would expect if a feature flag is disabled, if there's an issue communicating with like your upstream flag provider, whatever the case may be, this is like the last resort. This is the value that would be returned. We also have things like the description. So this should be human readable, a human readable description of the intent of the flag. It's typically not good practice to use a feature flag for other purposes. So you wouldn't want to reuse the same flag key in other places in your code. And this is a way to basically communicate what the intent of this flag is. And then finally, we can have things like the type of the feature flag. So this allows us to provide some type safety around some of the generated code that I'll show you in a moment. So the main idea for this manifest is it would live inside your application. It'd be version controlled alongside of your application, but it is not in the management tool directly. This is like a representative of the state that you would like to have in your management tool. And that's really where this concept of like feature flag driven development comes in. We want to treat your feature flag or feature flag configurations as a first-class citizen in your software delivery lifecycle. So we do that by defining the flags declaratively in version control, generating type-safe codes from the manifest, validating that flag configuration in your CI process, syncing the flags with your flag management system, and then finally, you're basically delegating control to your flag management system for environments like development and production. And this is all powered and thanks to OpenFeature. So if you're not familiar with OpenFeature, it's a vendor-agnostic specification and SDKs for working with feature flags. And you're able to plug into other flag vendors. So you can either build something from your internal systems or a commercial vendor. We have a passionate feature flag community. So if you're interested, there's a CNCF channel where you can just chat about, even if you're not using OpenFeature, if you just like feature flags, join us. It's quite interesting. And another big advantage of this is because we have this vendor-neutral interface, we can start building these like common shared tooling that basically everyone can benefit from. And one of the common tooling that we built is the OpenFeature CLI. So it has a couple of core commands like manifest, so we can add flags to a manifest. We can generate some code bindings from that manifest. We can validate it. So this is typically run in CI, but you could also run it locally if you'd like. You can push and pull to your flag management system. And all of that can be done with a quick installation. It's cross-platform, single binary. It's Go if you're interested in that. And because it's targeting the OpenFeature system, it would work with any OpenFeature provider. So let's kind of walk through a typical scenario here. So this is back to Kris's flow that he talked about earlier. So imagine like you as a developer, you get this ticket. It says you have to add a free shipping banner to your application. It's really high priority, and we want to put it behind a feature flag. So we'll go through the whole process here. Let's get to the IDE. So first, we'll start by defining the feature flag. So as you can see here, we'll just use the OpenFeature CLI. This will just kind of walk through the process of creating the flag in the manifest. So we just called it the free shipping banner. It's a Boolean flag. We'll say default value is false, and we'll give it a quick description of the intent of this feature flag. We're also including the ticket ID there too, so you could always reference back the reason behind this feature flag. And now you can see that it's in the flag manifest. So this is not in your management system yet. This is just locally in your code base, but also version controlled. So now that we have the flag manifest, let's go ahead and create the type-safe code bindings. So same thing, we'll head back to the OpenFeature CLI. In this case, we were using React, so we'll run the OpenFeature generate React command. And you'll see that we're outputting, in this case, some React hooks. But if you notice at the top, some of the JS comments here have that same information that we had in the flag manifest. So you can see the intent of the flag, ticket number, underlying flag key, etc. You'll also notice on line 34, that's actually accessing kind of the old technique, the thing that Kris mentioned earlier. So that's what you would have had to do by hand before. Okay, so now let's use it in the code base. So in this case, we'll just go to the main landing page, and then we'll import that new hook. So we're using VS Code here. Basically auto-completed, also auto-imported for us. It's an implementation detail, but kind of interesting there. And as you can see, like I'm hovering over, and you can actually see in your code base that reference to the JS doc that we talked about earlier. So you can see the intent, ticket, etc. We can also see if we were to use that value and hover over it, we do have the type safety. Of course, this is TypeScript, so you can actually see that this is a Boolean value. Now that we're here, we can go down and actually add the banner. So add it to this little section here, and we'll just do a little ternary and import our banner component, and then just add that message. Perfect. All right, so now it's time to test the banner that we just added. Go back to our code, and this is just a standard npm run. We're just going to run it locally, and this application here is our little fun demo app, so it's a little fun play on flags and toggles. And you can see that the banner doesn't exist at the moment. That was intentional. If you remember, default was false. Let's go ahead and toggle the flag. Cool, so perfect. That's exactly what we'd expect. We'd be able to expect to toggle this flag on and off at runtime because we have a feature flag there. Perfect, so now it's time to actually open up a pull request. We finished the feature. It's ready to get this into production. So we'll just stage our changes. We'll add a semi-useful commit message and go ahead and push this up to GitHub. Cool. So from here, we can see we'll just open up a pull request and not give it a description for some reason, and then go ahead and wait for the CI to pass. Here is some of the other tooling that we've been working on. So this is the OpenFeature CLI, or excuse me, the OpenFeature action, GitHub action. And basically what this is doing is it's looking at that flag manifest that we just did and comparing that to the flag management system and saying, okay, well, you just added the free shipping banner as part of this pull request. We have this configured so once you merge it to main, you're creating that flag for you. So it's basically programmatically creating that behind the scenes for us. But this would just be a way to identify that to the team and make them aware that this flag would be created as soon as this pull request is merged. From there, this is a vibe-coded flag management app we've created just to kind of showcase the concepts here. And the idea is, all right, now that we've merged this in, we're pushing that flag, so it's just created a minute ago. And this is basically where we're delegating the control from what we built internally as part of this pull request to the flag management system. So we can drill into our free banner app, or our free shipping banner. And then you can see here, like this is where you could actually customize the rollout behavior per stage or per environment. Cool, so we went from ticket to production. So we started by defining and generating our flags locally using the CLI in our IDE. Then we used that generated code and tested it locally. We were able to put our feature behind the feature flag and have that nice developer experience. And then finally, we were able to take advantage of CI to highlight the changes, communicate with the team, and then push those configuration changes to our flag management system. Before and after. So the process before, for the ticket, when you get the ticket, it's the same process as always. No changes there. Where it really starts to deviate a bit is like the flag creation. So you don't actually have to log into another tool. You don't have to mess around with that. You can just use the OpenFeature CLI to create it. In our code base, you can just type it manually. Or with the OpenFeature CLI, you can go ahead and generate that code binding. For opening the PR, of course, that's basically the same. It gets more interesting when we get into the code review, so you're actually automatically highlighting some of the changes for your development team. The merge, we can compare that to the source of truth to actually highlight what changes were made automatically, so you don't have to actually do that extra context shift. And then when it comes to deployment, you can have that confidence that the management tool, you basically delegated control to the management tool, and if you make a change there, it would be reflected in the app. And we feel like this is just the beginning. Future directions, we'd like to add more generated aspects. So there's things like the context in a feature flag evaluation, having type safety around that, and tracking events. We're also, as part of putting this presentation together, being able to test this locally more easily would be extremely valuable. So some kind of local flag overrides. Of course, we want to support more languages. We have a pretty good collection of languages at the moment, but the more the better. And we think there also could be some interesting MCP integrations, so more agentic workflows. If this is interesting to you, please consider looking us up on GitHub. We're active on the CNCF Slack. Kris, I basically found through this project. Like, he just reached out and just joined a Slack channel, I think, or at one of our meetings one time.
Like popped.
Like, two was the first person. So it's community around these concepts. Hopefully we're friendly, so feel free to join us. We'd love to work. Yeah, so to kind of recap, so we think this is an exciting future. We think feature flags are basically too important to be just an afterthought. We fundamentally believe that feature flags are part of the software delivery lifecycle, and it's really time to treat them that way, and that's why we think it's time for feature development.
Thank you. Thank you.
Yeah, we have time for questions, I think, if there are any. Can you use the mic, please? Yeah, go ahead.
Thank you.
Can you go in? Okay, yeah. Can you go into a little more detail on the generators? Like, I want to generate React code that calls my feature flags, but I have a particular context and a way we do it in my application. So is that just like can you write your own generator output for those?
So at the moment, no, but we were talking about basically it's just a Go template. So we're considering exposing that for people to customize. When it comes to providing context, like that's all supported as part of OpenFeature though. So you could supply, like we call it evaluation context, and that would be things like user IDs and
I meant like React context.
So we have a React SDK, so you can basically use that.
So like my application has a way that we expose feature flags and hooks already, like a used feature flag.
Like globally across the app?
And I just want to generate something that's just calling that using, from the metadata. So it would be React code, and using React context, but something that already exists that's like a wrapper around OpenFeature probably.
Possibly. I mean, so that's basically the way the OpenFeature React SDK works. Is it has a React provider, and basically the hook system taps into that. So I'd encourage you to look at that. But if that doesn't work for you, feel free to reach out. We can try to.
Right. Thanks. Great talk.
Thanks.
Thank you.
Is there any convention for varying those default values that you displayed before across some dimension that at the time of software release? For example, what environment, like dev or prod?
So we've tended to keep the defaults the same, like consistent across all environments. And typically for like Boolean, it tends to be off. We actually had that discussion, I think, earlier in the week as part of OpenFeature. It's like, it gets a little bit complicated if you're using a feature flag to like deprecate a feature, then you might invert, like, and make true the default value or something. So I think it's kind of up to like how you're using feature flags in some cases, but I'd probably try to keep it as consistent as possible.
Okay, thank you.
As an alternative to code generation, have you guys considered, IDE integration for code inspections or IntelliSense type discovery? So if we have large code bases using the older APIs, trying to convert those to the generated code may take a little while.
Yeah. I mean, we looked at that. I mean, it's certainly possible. It's still, on the table, but like ASTs and working with that for all these different languages become complicated fast. And this is a fairly easy and semi-elegant solution for it, I think. But of course, then it requires a bit of migration if you're not already using it. But if you do use it, then you get a lot for free. Like the compiler fights a lot of your battles. So I think that's the beauty of this technique.
Appreciate it.
Yeah, no problem. Alrighty, well, I won't keep you any longer. Appreciate the time and safe travels home. Thank you, everyone.